Now that you've had an introduction to what probability is, today we're going to introduce odds. Often when you're hearing about contests like lottery or other like sweepstakes and things, you'll hear about the odds of winning. Not quite the same thing as the probability of winning or probability of losing for that matter. Odds in favor, odds against, use probability, but the numbers come out a little differently. And as we go through this, just want to make a little comment about every year in my face-to-face class, I always bring up the McDonald's Monopoly game. For at least 10 years now, in their rules and their information about the game, they incorrectly use the word odds. The chances of winning. Yeah, I'm not going to point it out here right now on a recording, but just if you get a chance, look up the McDonald's Monopoly game rules and look up the chances of winning the prizes after you've watched this and learned about odds and the wording, and you will see what I'm talking about. How with the wording they're using, it's not they're contradicting themselves about what things are meaning. But anywho, all right. So what are odds? Let's look at that. You have odds against or odds in favor. Odds against an event is a ratio of the probability of something's failure, probability it's not going to happen, over probability of success, probability that it does happen. That's all it is. But it is a ratio of probabilities. So just the probability of failure by itself is not the odds against. The odds against has to be that ratio of probability of failure over probability of success. And then it reduces down a certain way. So odds against always has failure first, success second. So let's say you have a fair die that's tossed. Where did my pen go? Okay. Silly me, this isn't plugged in like I thought it was. All right. So let's say you're rolling a die, just a standard cubicle 1 through 6 kind of die. And you want to find the odds against rolling an odd number. So probability of rolling an odd number, probability of success, let's say you could roll a 1, a 3, or a 5. So you have 3 possible outcomes out of, or 3 desirable outcomes out of 6 total possible outcomes. And that reduces to 1/2. And probability of failure, not rolling odd, is also 3 out of 6, or 1/2. And what you do for odds is you put the probability of failure over probability of success. But notice that the denominators, the bottom numbers, are the same. And that's going to be true when you're doing odds. Your denominators are always going to be the same, and they're going to cancel out, leaving you with the numerators. And when you write the odds, typically what you do is you either write 1 to 1 like this, or you write 1 to 1. So it's a ratio. And the wording is 1 to 1. Probability of rolling an odd number is 3 in 6. In other words, there's 3 ways of rolling an odd number in 6 possible outcomes. But the odds of not rolling odd are 3 in 6, 3 out of 6. But if you want to say odds against rolling, it's 1 to 1. Different wording. And that's where McDonald's is running into their problem, is they're saying it's the odds of winning, and then they're giving the probability, or vice versa. Like they're not giving the right numbers based on the wording. Like if you say 1 in 6, That's not odds, that's probability. And that's what they're doing. They're saying 1 in 6 instead of 1 to 6. Totally different meaning. Now probability or odds in favor, same kind of idea. Like let's say you have, you're picking a card, pick a card, any card, pick a card from standard deck. The standard 52 card deck that I told you guys to learn about. And we want to see the odds in favor of selecting a spade. Well, probability of success, you're finding probability of selecting a spade. Well, in a standard deck, there's 13 cards that are spades out of 52 cards. Because spade is one of the suits, and there's 4 suits. 13 cards per suit. So that reduces to 1/4. And then probability of failure, not a spade, means you've selected some other card, a heart, a diamond, or an ace, or a club. So that's the other 39 cards out of 52. And that reduces to 3/4. Okay, so odds in favor puts probability of success, which is 1/4, over probability of failure, which is 3/4. And when you do this, your denominator is always the same. They're going to cancel out. If you want to go ahead and do the division process, the 4s will reduce out, leaving you with 1/3. But typically we write the answer either 1:3 or we write 1, 2, 3. So odds in favor are 1 to 3. So one way to get what we want to 3 ways to 3 ways to not get what we want. Whereas the probability of selecting a spade is 1/4. 1 out of 4. For every 4 cards, one of them will be a spade. So different meaning there. You know, different. The probability of success is different than the odds in favor. Okay, let's do one more where we're doing the odds. All right. Let's say we have a spinner. Divide it up into 3 equal parts. Remember, we're like equally likely to happen. We've got blue, yellow, red. And we want to figure first the odds against landing on red. So we need probability of failure, not red, because odds against, over probability of success, red. So odds against red. So not getting red, that's 2/3 of the spinner. Getting red is 1/3 of the spinner. The 3's cancel out, leaving you with 2 over 1. So your odds against getting red are 2 to 1. If you think about it, it makes sense. There's 2 ways to not get red to the 1 way to get red. Now if you want to do odds in favor, it's just the flip. It's probability of success over probability of failure. So then it's the 1/3's on top, 2/3 is on the bottom. So when it reduces, you get 1 to 2. So notice that odds against and odds in favor look similar except they're swapped. So you got to be really careful when you're setting these up. Make sure you're setting up correctly. If it's odds against, make sure you're putting probability of failure on top, success on the bottom. And if it's odds in favor, make sure you're putting success on top, failure on the bottom. Because just if you get one, you just swap it to get the other. Now what you might notice too when you're doing the odds, probability of success plus probability of failure is 1. Like if you go back to the previous slide, probability of success was 1/3, probability of failure was 2/3. You have 1/3 plus 2/3. That equaled 3/3 or 1. But notice too that the numerators 1 and 2 add up to the denominator. And those numerators also are what make up the odds. Like you had 1 to 2 or 2 to 1. Those numbers in the odds, they add up and equal this denominator. So if you are given odds, you can actually work backwards and figure out the probability of success and probability of failure, knowing that. If you're doing, if you have odds in favor, then the first number is part of the probability of success, second number is probability of failure. If you have odds against, first one's failure, second one's success. And these numbers in the odds are your numerators. Then you add the two numbers together, that'll give you your denominator. Okay, for instance, odds in favor of Wendy winning an election are 7 to 4. And we want to use this to find probabilities. Well, remember, odds in favor means you had probability of success over probability of failure. So the 7 was on top somehow. It was the numerator for the top fraction, and the 4 was the numerator for the bottom fraction. So how do we get the denominator? We add the 7 plus 4, and we get 11. So the probability that Wendy wins, so that's success, is 7 over 11. Probability that Wendy does not win is 4 over 11. And notice if you add the two together, 7/11 plus 4/11, you get 11/11, or 1. All right, one more example. Birth defects affect 1 in 33 babies born in the U.S. each year. I think they're just saying any, like, including all types of birth defects. My son and I are each one of those 1 in 33. For birth defect called craniosynostosis. Some of our sutures in our skull were fused prematurely, and we had to have skull surgeries to reconstruct our skulls. It's been quite a ride. All right, so birth defects affect 1 in 33 babies born in the U.S. each year. What is the probability that a baby born in the U.S. will have a birth defect? Well, the problem, the way it's worded, tells you 1 in 33. So for every 33 babies born, one of those has a birth defect. If you want the probability of no birth defect, then that has to be 32 over 33. Because these two have to add up to 1. Probability of something happening plus probability of something not happening has to add up to 1. So no birth defect has to be 32 over 33. If you want odds against A birth defect for US baby. Then the top fraction has to be no birth defect. That's failure of having a birth defect. In this case, failure is a good thing. And then success is probability of having a birth defect. In this case, success is a bad thing. 33's reduce out, leaving you with 32 to 1. Or you could write 32 to 1. But notice the difference. 1 in 33 gave us probability. 32 to 1 gives us odds. All right. Well, lots more practice problems similar to the ones I was just doing with you. Make sure you tackle this section, try as many as you can. And when we come up again next time, we're going to look at expectation. We're going to look more carefully at games and this will help us to figure out whether it's worth playing a game or not. If you play it enough times, do you come out ahead or do you come out losing? So might be something to think about next time you want to buy a lottery ticket. But for now, thank you for joining us, and we'll see you again soon.